Hi guys, in this video we are going to take a look at using method of Lagrange multipliers to find the maximum and minimum values for the function f of xy equals x squared y, and it is subject to a constraint 7x squared plus 5y squared equals 105, which is an ellipse. So the first thing you do is you find the gradient of the function you're trying to maximize or minimize. So that would be just the partial derivatives as a vector. So if you take the derivative of x squared multiplied by y, you think of y being a number, so you keep it, and then derivative of x squared is 2x. So that will give you 2xy. Then derivative of x squared y with respect to y would be x squared, because x squared is going to be like a constant multiple. And then the constraint would be this part. So you can call this g function. They actually include the 105. They move it to the left-hand side so that the constraint becomes g of xy equals to 0. Usually they want 0 on one side. It doesn't matter in terms of the derivatives because the 105 is going to become 0 anyway. So here you have gradient of g, and that is 14x. And if you multiply 5 by 2, that's going to be 10y. All right, so what you're thinking about is the method of Lagrange multiplier says that the gradients should be proportionate to each other. So there is this constant lambda, which is called the Lagrange multiplier, so that the gradients are multiples of each other. And also the points, wherever these points are, the solutions, they also have to satisfy the constraints. So you have to be on that ellipse, 7x squared plus 5y squared equals 105. Now, normally what you would have to do is worry about either x or y being 0. So if you don't worry about that, so what I'm going to do first is I'm going to say, okay, let's assume that x is not 0 and also y is not 0. So we do not have to worry about dividing by 0. Then when we say that the gradients are proportionate to each other, that just reduces it to the x component divided by the x component is equal to the y component divided by the y component. So the proportion has to work. And we'll come back to the case when they are 0, if one of them is 0, later on. But right now, let's just set this proportion. And the way we solve it is usually we cross multiply. However, before I cross multiply, I'm going to cancel some stuff. So for example, here I see an x, here I see an x. Again, I assume that x is not 0, so I can cancel it. I also have a 2 and a 14, so I'll just leave 7 over here. And so that will give me y divided by 7 equal to x squared divided by 10y. And at this point, I am going to start cross multiplying. So I just want to get rid of some things that can be canceled so that my life is a little easier. So cross multiplying this means that you multiply this by that right there, right? And multiply this part by this part and make them equal each other. So that will become 10y squared equals 7x squared. All right, so that's what we got. We got a connection between y squared and x squared. Now, we also need to note that the constraint has to be satisfied. So let me rewrite the constraint again. So that would be 7x squared plus 5y squared equals 105. So I see the 7x squared right there, and that is 10y squared. So I'm just going to substitute that, and I will get 10y squared plus 5y squared equal to 105. All right, so that gives me 15y squared equals 105. Now I'm not sure whether 105 is divisible by 15. I think it is, but let me just double check that so I'm not going to lie here. That's going to be 7. Okay, so that tells me that y squared equals 7, which means that y is either going to be plus square root of 7 or minus square root of 7. So this is really plus minus. Okay, so let's see if I can fill out the stuff that I already have. So this is 2xy. Here we got x squared, sorry, and here I have 14x, here I have 10y. Okay, so let's do that. All right, and so we got the y. Now, in terms of x, we have the connection between them, and the connection is right here. This is what we found when we would cross multiply. So we have x squared. X squared is 10y squared divided by 7. Notice that in the function that we're trying to maximize and minimize, there is x squared in there. So we don't really need to get x, we need x squared. And so if I know that y squared is 7, that just gives me 10 divided by 7 multiplied by 7, and that gives me 10. Okay, so if I have these points, and basically these points are going to be x is going to be plus minus square root of 10, and y is going to be plus minus square root of 7. So actually you have 4 points here with varying signs. Okay, those are going to be your critical points, assuming that none of x or y are zeros. And if you substitute these values into your f, the largest of them will give you the maximum and the smallest will give you the minimum. So if they're both positive, that will give me, for x squared will just give me 10, and then y would be square root of 7. Okay, so now what would happen if, for example, they were both, let's say, negative? So if this was negative and also the other one is negative, then when I square a negative, that becomes a positive. So that will be 10, and then this is going to become negative square root of 7. Okay, so that's going to be the value. So the negative we can pull out. So that would be negative 10 square root of 7. Now, if one of them is positive, let's say you got square root of 10, but then negative square root of 7. Well, that's going to be exact same thing, because when you square 10, that's still going to be 10. So this will be the same. So that will be negative 10 square root of 7. Finally, if they're like, let's say, which one I did not do. Okay, so maybe the first one is negative, the second one is positive. Well, the squaring of a negative, that's not going to affect anything. So that's going to be a 10, and then again 10 square root of 7. So what we see from here is that likely what will happen is the maximum will be 10 square root of 7, and the minimum will be negative 10 square root of 7. Now, you could say, okay, well, hello, you did not check what if either x or y is 0, right? Like, what would happen? Well, here's the deal. If x is 0, then the function f at 0, when x is 0, it will be 0, right? And if y is 0, then again, our function is also going to be 0. But that's not going to be a maximum or a minimum, because we already know that at other points that satisfy the constraint, we got a larger value. We got 10 square root of 7, and we got negative 10 square root of 7. So the max or the min will not occur when x is 0 or y is 0. So we don't really have to worry about those values at all. Okay, so we are basically done.